Okay, so hi everyone. So this video is going to teach you how to draw the structure of ionic compounds. So let's start with the first example, sodium chloride. The first thing to do is to find the formula of that compound if it is not given to you. If it is given to you, you can start directly, but let's say nothing is given to you, so you just know the name of the compound. So sodium is Na, chlorine is Cl, valency 1, cross multiply, you have the formula NaCl. So now you can start to find the structure. So because it is an ionic compound, definitely there's going to be one metal and one non-metal. So let's start with the metal. So the metal is sodium, so Na. Valency of Na, because Na is found in group 1, so it is a group 1 element. Because it is in group 1, it will have valency 1. And because it has valency 1, it will form the cation Na+. Okay, so what is the structure of the cation? So sodium, if you look in the periodic table, sodium has 11 electrons. It is in group 1. So 11 electrons means that normally the atom will have electronic configuration 2, 8, 1. Okay, but because it is a metal, it will want to have the structure of the nearest noble gas. So the nearest noble gas is neon here. So it will want to have the electronic structure of neon. So it's going to lose that one electron. And when it loses that one electron, it becomes Na+. Okay, so structure of the cation. So let's start with the atom first. So Na. So 2, 8, 1, 2, 8, 1. That is going to lose that one electron to become Na+. And because it has lost that one electron, so it's now completely filled. The outermost shell is now completely filled. Okay, but it will have a charge of plus. Okay, so that's Na+. Now, the non-metal here is going to be chlorine. Chlorine is in group 7. Chlorine is in group 7, and it will have valency 1. Because it has valency 1, it will form Cl-. Remember, the charge of the particle depends on the valency. So valency 1 means it's going to form -1 because it is a non-metal. Okay, now structure of the anion. Right, so chlorine has 17 electrons. So chlorine with the 17 electrons, so 2, 8, 7. Okay, so because it is a non-metal, it's going to gain electron and it's going to become Cl-. Okay, so let's draw the Cl first. So 2, 8, 7. For this one, let me use dots for this. 2, 8. I'm sorry that my dots look very irregular. Okay, 2, 8, 7. Okay, now this is going to gain electron. So it tells you show electron gains from the cation. So where is that electron that it's gaining coming from? So it's going to gain 1 electron. Why 1 electron? Because it has valency 1. So if it would have valency 2, it would gain 2 electrons. If it would have valency 3, it would gain 3 electrons. So when it gains 1 electron, So that's what we have. Gains one electron, and that one electron is coming from the sodium. So it's that one electron, that one which is lost. This has been gained by chlorine. So I'm going to include that cross here because it's showing that the electron has been transferred. Okay, and because it is an anion, I will show the negative charge. Negative and positive charges will attract each other. The brackets are very important for you to include and for you to include the charge. So the ionic compound has a structure of Na. So I'm going to draw the two structures next to each other. So that's a neater diagram. So sodium is going to form Na+, and I have all the electrons as crosses, and chlorine is going to have all these electrons, and I've shown the electrons of chlorine using dots, and then there is that one cross here which is from so that one cross over here, this is the electron that was from sodium that got transferred to chlorine. Okay, so this is very important. Any one element can be cross, any one element can be dots, it doesn't really matter. But what matters is that you show the electron transfer in terms of, so one will have dot and cross in its diagram. It's very important to show this because this is what is showing that transfer has taken place. So it shows that the electron from sodium got transferred to chlorine. Okay, so that's the structure of the ionic compound NaCl. Let's see another example. Lithium fluoride. So again, I'm going to start from the formula. Lithium, fluorine. Lithium has valency 1, fluorine has valency 1, LiF. So that's going to be almost similar as NaCl. So lithium, group 1 valency 1, Li plus. Structure of the cation. So if you look in the periodic table, lithium is over here. It has 3 electrons. So from Li, so lithium has 3 electrons. So that's going to be 2, 1. And it's going to lose 1 electron to become Li plus. Okay, so this one is going to leave. Fluorine, valency 1, anion form F minus. Structure is going to be, so if you look at fluorine in the periodic table, fluorine 9 electrons. So it's going to be 2, 7, because it's F9 electrons. Okay, right, so that's fluorine. I've used dots for fluorine. That's going to gain 1 electron, and it's going to be, so you see all the dots. You can either show the dot like that, or you could just show it like that. Okay, so you see here, there's 1 electron that has been gained, and that 1 electron has been gained from the lithium. I will put the charge minus here. So then the structure would be, so that how is the structure going to look like? So fluorine has 1 electron that has been gained from lithium. So it's F minus, Li plus. They both attract each other because of electrostatic forces. It's very important to show the 2 ions close together because the electrostatic force is going to bring them together. Don't show them far apart. Okay? Let's see a last example, and then you're going to do the others on your own. So magnesium fluoride, that's Mg, fluoride is F. Magnesium has valency 2, F has valency 1. You cannot simplify, so it is MgF2. So now you will see how to represent the formula, the ionic structure when there is two of a certain element. The metal is magnesium. Because it is in group 2, so valency would be 2. Cation will be Mg 2+. So the charge depends on the valency. If you look at magnesium, magnesium has 12 electrons. So let's show these 12 electrons. So 12 electrons would be 2, 8, 2. So 282, it's going to lose 2 electrons. Okay, so these two are in excess. So it will lose 2 electrons, lose 2 electrons. These two go out. So once it has lost these 2 electrons, so it has an outermost shell which is completely filled, and it is going to have a charge of 2+. Do not forget to include the charge, very important. Let's see the anion, the non-metal, F, valency 1 because it is in group 7. Anion form is going to be F-. So structure of the anion, just like we did in the previous example. So fluorine has 9 electrons, so 2, 7. So when it gains 1 electron, so that 1 electron is coming from the magnesium. So do not forget to include the charge. Okay, for now we're ignoring how many fluorine we have. Okay, we've just seen what are the anions and cations formed. Now for the ionic compound, now we'll look at the formula, which is MgF2. So we're going to draw the Mg and the F, and then we'll see what to do with the 2. So now I have the Mg 2+ and the F-. But if you look at the formula, you see there is 2F, so 2 fluorine ions should be there. There's 2 ways of doing that. Either you draw the fluorine again on the other side of the metal, of the cation magnesium. So you're going to have 2 drawings that look like this. Or on that same drawing, you're just going to write a 2 in front of the F. So 2 dot in front of the F. This shows that, So this shows that there is 2 fluorine ions. Okay, so you can just include numbers in front of the ion, either the cation or the anion, if you want to show how many of the ions you have. Okay, now you're going to try the other examples, and all of this is going to be in your copybook. Okay, take your time and do these right. Now, if you find that you don't need this table, actually, no one is going to ask you to fill in this table in the exams. That's just for you to know how to do it. If you don't want to do it in the form of a table, it's fine, as long as you understand the process, the thinking process going on, and as long as you respect the charges and you respect the numbers and the valencies formed. Okay, so one thing important, make sure you include the charges. Second thing, the actual number of ions in that compound. Third thing, you show dots and crosses in your diagram. Okay,